Okay. So, as I mentioned, this presentation is part of our continuing e-learning series. We've been offering this now for I think 6 or 8 months, and there are, as we complete any of these e-learning seminars, we typically record them because they're all run via WebEx, and we may also have a PowerPoint document that you can download in PDF form to go through the actual presentation. Just a quick reminder, there's lots of them out there. We've been doing this for a while. They seem to be very popular, very helpful. We're getting good feedback. If you go to our website and just search on e-learning, you'll see the entire list of the seminars that have currently been offered and we're planning on offering in the future. And again, you can simply sign into the website and download either the recording or view the recording live, or you can download the PDF file. If you are joining us from New York or New Jersey, if you attend the full webinar and complete the survey that Christina will email to you afterwards, we can supply you with continuing education credit towards your PE licenses. I'd like to mention this because it's still fairly new. We have a brand new website at caeai.com. It's the same URL, so you go to the same place, but we have a whole new look and feel to our website. Things have been reorganized, hopefully making them easier to find in terms of these e-learning seminars, our training schedule, the ability to register for training, case studies, and we've even opened up or begun a new CAEA engineering blog. And so feel free to check out some of the blog articles that have been placed. Comment as you choose to, and we're going to be monitoring the blog comments and responding to them as quickly as we can. So again, I encourage you to take a look at our new website, and any feedback that you may have, you can send email directly to Christina, as she is the manager of the company website. So let's talk about today's topic, getting the most from your workbench model. We've thrown around a couple different terms here, like using your model as a template, but essentially what we're after here is trying to take advantage of some of the key aspects and key tools that are built into the ANSYS Workbench environment that allow you to get maximum usage out of your model. Oftentimes, you're in a design scenario where you have tables of designs or families of designs that are somewhat similar in nature. The basic analysis method that you're going to follow is the same, the loading, the driving parameters for the geometry. And when that's the case, you can very easily, with a little bit of upfront planning and forethought, you can set up your first mechanical model such that you can then substitute in additional models that, again, meet that same criteria for the nomenclature of the parameters that we've used and the name selections. So now we've gone beyond the ability to simply put in parameters. We've added now the ability to also make the geometry uniform and parametric. So the key to accomplishing this, as I mentioned, is to have a little bit of planning up front and develop for yourself a consistent or recognizable set of names for both your parameters, your name selections, and we'll also talk about utilizing your coordinate systems. So that's another aspect of the model that can be shared between various CAD models. So as an example here, step one, let's go in and let's take a look at the geometric parameters. This is something that we've had the ability to do since the beginning of Workbench. So it's our first place to start, and I'm just giving you a couple of basic examples. I'm going to analyze a flanged pipe connection with some bolts in it, and then I'm going to substitute in something that's shaped completely differently, but is essentially the same idea. So I have some basic parameters that I can share between these two different geometries. Things like the length of my pipe, the wall thickness of the pipe. These are all parametric. They don't have to be the same actual value. We're just simply going to substitute them in and use the parameters for parameter values for the particular design that we're dealing with at that time. So just a couple of examples here. Again, it's always a good idea for you to develop not just a nomenclature that you can be consistent with across different families or members of that family of designs, but also the parameter names that are going to make sense to you, because when you're in the Workbench environment, there's no way for you to click on that parameter name and see it highlighted like you can on the CAD side. So the more recognizable you make these parameters, the less time you have to spend going back to the original CAD model to try to figure out what the parameter was. So the parameter names shown in column B are the ones that we're defining. The ones in column A are the ones that ANSYS is assigning to the name that we've provided. So we also want to develop consistent nomenclature for things like coordinate systems. Very often we're using coordinate systems for directional loading. We're going to talk a little bit about construction geometry and directional result items. So coordinate systems are very useful if you have a datum plane in your CAD model that is spaced and located and oriented in the way that you're going to utilize on the mechanical side. By all means, bring it right into the mechanical environment. You can bring it in through Design Modeler. Any information that's brought in, these name selections, parameter names, and coordinate systems can come through Design Modeler and still be passed into the mechanical environment. So there's no restriction as far as whether you go directly from CAD to mechanical or include Design Modeler in the loop. So in this case, you can see I have an example here where I'm going to do a force summation at a particular location. So I'm going to define some construction geometry and use that to do, for you mechanical APDL users out there, to do an F-sum, essentially, in Workbench, one of the things that we can do. And keeping that plane sort of uniform, I can use it again in my subsequent geometry. So now we get to the real crux of how to do this effectively. We've already known about parameters for a while. Coordinate systems, are useful to some degree, but we can essentially get away without them in most cases. But the key to making this particular method usable and continuous and persistent is to use the name selections. The name selections being the groups of geometry that we can define at the CAD level, at the Design Modeler level, and then subsequently also at the mechanical level. So we can start out, I'll give you a simple example, we could start out with some geometry at the CAD level. We bring that into Design Modeler. We may add some geometry to that. We could create another name selection of the new geometry, create an assembly of the old and the new together as a name selection, or do that at the mechanical level. You basically have full transparency for these name selections from CAD all the way down to mechanical. And hopefully most people have had a chance to use this. The CAD Name Selection Manager is built right into the API. I'm showing you an example here of SolidWorks. You'd simply pull down the ANSYS 14.5, in this case, pull-down menu, and you'll see that the ANSYS Name Selection Manager, that pops up this little window in your CAD interface, and you select Geometry, select Create, and it'll prompt you for a name for that particular section of geometry that you'd like to save. So we'd like to do this as much as possible, because the more you do up at the CAD level, the more you're going to be able to utilize these name selections throughout the process flow as you work your way down through Design Modeler and then into mechanical. So what can we do with these name selections? Well, there's very little that we can't do at this point with name selections. They are all over the mechanical interface. We're going to show this example here where we've defined the entire model via name selection definition. I'm not picking a single piece of geometry at the mechanical level. So we can define things like symmetry regions if we're using the symmetry folder, contact or joint connections. We can specify, it's almost easier in some cases to utilize name selections than it is to do the automatic contact generation, because when you use the name selections, you know exactly what you're picking. And you'll see, for instance, in the case of the contact, that the target and the contact face, you just simply switch from geometry selection to name selection, and you pick them from the list. So as long as you get them into mechanical, they're all there and they're all usable. And again, these names are now keyed into this particular mechanical model. So if we want to bring in a similar geometry that has those same name selection names, all of these settings are going to be mapped onto the ones that we've chosen. So continuing on with our name selection options, we can define mesh controls. Anywhere where you would be picking geometry, you can substitute in a name selection. So loads and supports, imported loads. For instance, if you were doing a sequential thermal structural analysis and dragging and dropping the solution from your thermal analysis onto the structural analysis, or using the external data utility, you can map that onto specified locations that can be defined via name selection. And then lastly, and most importantly, we're going to be scoping our result items to particular areas of the geometry. And once again, why pick geometry when you can use name selections if they're there in the model for you? So basically what we're trying to emphasize here is that you can set up and run an analysis system, and it can be basically a complicated schematic of various different types of analyses, like a structural steady-state thermal, supplying temperatures to a static structural, which then would supply pre-stress to a modal, and so on and so forth. Once you've got that schematic, or an analysis schematic, set up in place, if you're defining all this with name selections, you could just simply substitute in a new geometry. You'll notice on the geometry row, you right-click and there's an option to replace geometry. Put in the new geometry, provided that you've used the same nomenclature for those name selections. Everything automatically gets remapped onto this new geometry. So let's take a look. Let's show an example of that here. I'm going to start out at the design modeler level here, and this is that basically flange pipe that I was talking about. And this could have, as I mentioned, started at the CAD level. It could have come down through design modeler. I could have done additional defeaturing operations here. It doesn't matter whether I start at CAD or design modeler. In this case, I'm starting at the design modeler level, but you get the idea. And you'll notice as you go through my design modeler history that I've done a series of things with the intent of being able to reuse this model. So I'm thinking of areas up front that I'm going to want to have access to when I'm applying mesh controls or boundary conditions or result scoping. For instance, some of the contact regions here. I have something called the nut contact face. That's the underside of the nut. Let's scroll down. Free convection surface. So this is an area where I'm going to apply a free convection coefficient for my thermal analysis. I also have the internal surface defined as the pressure surface. So I'm basically thinking up front about how I'm going to analyze this part at the geometry level so that I can reutilize this model to its full extent. So we'll do things like that. We'll also bring over some coordinate systems, like this is my bolt pretension direction for the coordinate system. And the key to bringing coordinate systems over is to simply come down to the bottom of the details menu and change the export from its default no to yes. And on the design modeler side, any coordinate system by default will not be exported to mechanical because they don't want to flood your mechanical environment with all these systems. So you're going to pick and choose specifically the coordinate systems that you'd like to bring across. If you are bringing coordinate systems in from the CAD tool, in the details of the attach function, you'll see the name selections that were imported from CAD, as well as any of the coordinate systems that have come across. And then additionally, we're always going to be looking to find ways to study a sensitivity of a particular design, now a family of designs, using our parameters. So I've got my parameters shown here down on the bottom. So my system, let's bring that over now here, is simply going to be, I've got a geometry item where I've developed the geometry or imported from CAD. I drag and drop that into a steady state thermal analysis. In this case, I happen to be using the same mesh between the two models, but that's not even required because, again, we're essentially mesh independent when we start using these name selections for the boundary conditions. I'm using the thermal result as a structural load, so I drag and drop the solution of the thermal analysis onto the setup. So I've got essentially a basic schematic here in mind. Now, some of you may have seen down under custom systems the ability to develop your own system here when you've developed this analysis schematic. And that's all true. If I wanted to save this as a custom system, I could just simply right-click out in the open and tell it to add to the custom menu. But I want to caution you about this because these operations that we're performing at the project level don't or are not aware of anything that happened inside the mechanical interface because the mechanical environment is still what's called a data integrated interface. It's not built in or written in the Python format that the project menu is written in. So until we get to a point where design modeler and mechanical are all inside this same project window, we're not going to be able to really fully utilize this custom system capability. For the time being, what we're going to do is set up the model and then make a copy of that model. Just simply save as from the project page, substitute in our new geometry. So let's take a look at our mechanical model, see how we set this up. We'll bring over mechanical. And just going right from the top, I mentioned construction geometry. I have a surface that I defined that I call my F-sum surface. So I'm going to take the sum of the forces in between the bolts on one side of the flange. In order to set up a surface to map results onto, I need a coordinate system. Well, I can use any of the global coordinate systems that come in. I could define my own local coordinate system at the mechanical level. But again, for consistency standpoint, I'm going to want to use a coordinate system that was developed and common between my various designs at the CAD level. So I've done that here. I've imported a coordinate system called F-sum plane, and I've made my construction surface defined at that particular coordinate system, F-sum plane. Symmetry. When we bring in our symmetry tools, if you've defined symmetry in the geometry model, in Design Modeler, that will automatically result in a symmetry region on your mechanical model. In this case, I did not do that. I wanted to define them manually, so I simply would right-click, insert a symmetry region, and then again switch from geometry selection to name selection, and then you'll see, or you'll have access to all of the name selections that you've brought into the mechanical model. If you're having trouble finding them on this little menu and you want to make sure that something is there or not there, anytime you've brought in name selections, they will be added to the outline tree. So you'll have your full list of name selections shown in the outline tree itself. So it's a quick and easy way for you to double check. Let's say you had made a mistake in the number of surfaces that you had selected on your name selection. You can always go back here and edit it locally in mechanical, even though it was developed up at the CAD level. Don't recommend that you do that. I think it's more consistent if you start up at the CAD level whenever possible. But again, these are not hard-coded in any way simply because they were imported. They're imported, but you have the ability to edit them at will. So back up at the top here, we define a symmetry region. We pull down from the list here. I don't want to add one in here because I don't need it at this point. Because I've got one at that face. I've got another one in which I called my axial sim face. Again, these are all imported from the CAD tool. So let's go down to the next step here. Let's look at our CAD connections. I have found that the ability to create these connection groups and locally define discrete regions of connection between the model via name selections, for me, is far more convenient and far more intuitive than using the automatic contact tool. You can use the automatic contact tool. It'll generate a whole bunch of regions. It's still up to you to go back and find these regions and edit them and make sure they are what you want. If I've already defined the surfaces, I like to create, as you can see here, various folders so I can categorize and keep track of where my contact regions are. I find that as I go from model to model, it's much easier for me to go down and check because I've put some thought into the way that I'm connecting these parts together, and I know exactly where to look to make sure that these contacts are being updated correctly. So I've got a connection region that I call a flange to pipe. That's my in this case, a frictional contact or nonlinear contact between the two flanges. And if you look down on the bottom here, I've scoped it to name selection, and I have defined my contact and my target faces as top flange, bottom flange. So these are name selections that, again, came in from the CAD system. I also did that with my bolts. So, again, the bolt to the top of the flange, and then the nut to the underside of the flange. I have bonded contact there. And then I've got a bonded contact between each one of the bolts and the nuts, assuming that I have sufficient friction there to treat that as bonded. So again, I have become a big fan of using these contact folders. You can still create the automatic contact and then drag it into the folders that you want to organize things. And once you've done this, very key aspect here, once you've got your contact regions defined and narrowed down to what you want them to be, go up to the connections region and turn off the automatic contact correction. The automatic contact connection is going to be on by default. So you can go through all this effort. You can get your contacts where you want them to be. But if you go and substitute in new geometry and it refreshes, it's going to go and create a whole series of other contact regions that you may have either deleted or edited. It won't change the ones that you've defined, but it'll add in a bunch of additional ones, which you'll then need to clean out. So basic rule of thumb here, bring your model in the first time, define all of your contact regions, and once you've got them in the order that you want them in and all set up, turn off the automatic contact generation for subsequent refreshes of the geometry. It's just going to save you a lot of time and effort. So just continuing on, we have some my mesh controls, again, defined by name selection for my hex dominant, for my multi-zone meshes. My convections, once again, defined by name selection. There's my pressure surface. There's my convection surface. My heat flux, in this case, is scoped to a particular body in the model via name selection. Again, I think you're getting the basic idea now. Same thing with my bolt pretensions, my internal pressure on the structural side. I have a displacement. I had to put in a single displacement point to take care of the last degree of freedom that was open, the vertical direction. And again, I put in a name selection called vertical constraint at the CAD level, was able to grab it here. So that's basically the idea. We're setting this whole thing up, right down to the scoping of the results, from the very top of the model. Now, what can we do with this now? If we've done this consistently, how can we now reutilize this model? Let's go back to our project page here, and typically you'll save a copy of this. You could right-click and duplicate the model and substitute the geometry there. But let's just show you very simply how we can substitute in different geometry right into this. So assuming that I save as, I now have, iteration 1, this will be iteration 2. I simply come up to the geometry, and I right-click, and, oops, that's not what I wanted to do there. Looks like I froze up. Let's do it a different way here. Bring the geometry into this point. I'm going to bring in a different geometry called the rectangular pipe, and I just sever the link here. Right-click and reconnect it. And I want to make sure that my properties are all set up the same way. So I should have all of my parameter prefix and everything set up as I intended. And if I did everything right here, when I refresh this model, bring our model up here. And it goes through. It should be rereading the geometry. You can see it's now bringing in this square flange. And once again, the square flange had that consistent set of nomenclature defined for the symmetry regions. Half symmetry face is there. The end symmetry face is there. The mesh control on the various parts, again, because they're all toggling to the names of the bodies that we've selected. They're now persistent, and they've been added. There's my internal convection, my external convection, right all the way down to the scoping of the contact region to a particular body. So that's really all there is to it. It does require, as I mentioned, some forethought and some planning at the beginning of the process. But when you do that, again, you can get the maximum usage out of that model. You set it up one time, and you can use it for multiple designs. In addition to that, the parameters are also persistent. So when we open up the parameter set, we'll still have the ability to populate a design table or use Design Explorer with that same model, because everything else works exactly the same as it did with a single model. You've now just simply substituted in or snuck in, I guess, under the door a different geometry file that's using the same nomenclature from the standpoint of the parameters and the name selections.